So on number 9. This is 511. So the front of it looks like this. I think I gave you this. I don't know if I have any more extras of this. Yes, I do. Maybe. These are all the fronts. You can have this one. This one I did the top part here, but the rest of it, like the back, will still be done. But I thought I gave you that, but it's alright. If I didn't, my bad.
I found Antonella's thing in my binder.
Weird. Well, good thing it was already mastered. Alright, thank you very much. Where is Antonella now? Will you hand that to her? I don't know how Kylie ended up with this, but she ended up with your paper. Alright, so I just gave away the back of my paper. So give me a second and I'll pull it up in Google Docs. The 10 on the bottom should have had a percent sign. Oh, never mind. I do have the back. I'm just crazy. So this 10 should have actually had a percent sign, meaning that B is representing 50%, but on the top, we're not talking in percentages, we're talking in numbers, like the numerical amount, like we were doing with grams of fiber or grams of protein. So if 144 relates to 40%, we can chop that in half and say this span that is 20% would actually be 72. Any questions on 9? Guys, 10 says to create a drawing to represent this situation like the one above, but you don't have to break up every 10%. So your drawing could be as simple as saying a little bit more than half is what is filled right now. That is 55%. You don't have to make your drawing super complex. You don't have to have all the tick marks. It would be nice if you did, but you don't have to. If that's what we have filled right now, how much left is there to get to 100%? What percent are we missing? Anyone? 45, right? 45%. Then how many gallons are in the tank right now? Guys, look at the dry erase board. What's written in blue, it's what we were doing yesterday with like calculating the percents. So grab your calculator. I should see a bunch of calculators coming out right now. Grab your calculator. Oh, I forgot what was going on yesterday. I need white paper behind my calculator for this to show my calculator. I don't know why I didn't realize that, but that's what was happening. At least I got it to work later in the day. And now it probably won't again. We're going to do 55%, which is 55 out of 100. You can either literally put 55 out of 100. I don't know how it's supposed to work. There we go. Or you can put 0.55. Either way, do that times 80. So I'm going to show you both ways. That's what we should have. We should have 44 gallons in the tank right now. So here's the reason not to do that. You won't always have that calculator. So you want to get used to fractions being division and percents turning into a fraction or a decimal. So guys, some calculators have a percent button. I really want you to avoid using that because that takes away some of your thinking and your learning. So if there are 44 gallons right now, we could either subtract to find the leftover gallons or calculate percent again. Lucas, you had your hand up? Okay. Now hold on, we would want to label this that 80 gallons over 100. Okay, with you.
And then that can go down to 8 gallons and 10%, which is also 4 gallons and 5%. And then you multiply it from there to get 55%.
Now you got to be careful though, because at some point you did have a goof up in figuring out this section of how much is left, right? That's why I marked your paper like I did, because I think you had like 24, 28, something like that. Our 45% that is left, guys, let's think about Lucas's method, because it's sweet. 45%. Lucas told us 10% is 8 gallons. So if I do 4 of these, what's 8 times 4? 32 plus another 5% or another 4 gallons. So we can do the Lucas method of break it into 10% or 5%, or if we have a calculator, we can do the 45% times 80. Either way, this span that is left should be 36 gallons. So this answer was 44. This answer was 36. Both of them need a label, gallons. All right, I'm going back to the answer key because unless you have questions. So look at number 11 here. Our answer for A should have been 15 over 24. Answer for B was we fill in 4 over 4, and then that top number, that numerator, turns into a 36. Any questions on A or B? C, our giant one starts to become fractions here. This is where it gets a little tricky. So I'm guessing people, I can pretty much assume at least half of us probably at least had to think twice about this. Maybe you ended up with the right answer, but you probably had to think twice. If we don't know how to multiply, what can we do? Divide backwards. So take your 110, divide it by 20. That's how they get their 5.5. So that's how they know what to multiply by. On top and on bottom. Do that to your 7, and you get 38.5. Same thing for D, except when we do the division backwards, it tells us it's 0.6. That's what we're multiplying by because we're getting smaller. And then our answer becomes 26.4. Questions? There's not much reason for those to not be done at this point. Pretty much did them for you. I changed what 12 asked you because I didn't love it. Kids in the past have not loved making these. So what we needed to do for 12 was different than what you maybe would have seen if you went to homework help. It says use proportional reasoning to solve a unit rate. I'm going to highlight that. What's a unit rate? Why do we say unit? Per 1. Unit rate is per 1. So if it was 40 hours, which is a normal work week, and actually, guys, you go to school. Oh, it's longer than 40 hours, but I forget what it is. You go to school longer than 40 hours each week. Your school week is longer than an adult work week. That's why we make Fridays shorter, because our week was already longer. But if we want to do dollars per 1 hour, guys, I went ahead and gave you the really giant hint here. We're trying to solve for 1 hour. Dollars on top. If you flipped this over, you would have gotten an answer that really didn't make sense. Dollars per top, or dollars on top, sorry. Hours on bottom. We do the division. Again, grab your calculator. We're doing difficult math now. I typed that in wrong. Always double check that you've typed it incorrectly. 11.34. Not bad. Would you take a job for $11 an hour? I mean, I used to. I used to work jobs for $7 an hour, guys. You better realize when you first start working, you don't get paid a whole lot. I sat in a chair and told kids to stop running. How much do you really think I deserve to get paid? No, I was a lifeguard. Now, if I had to actually do something, I did have training. And 513. Here's your answers. If anyone needs me to go over them, I will. But we're just multiplying or adding or subtracting fractions, which we've practiced a lot of. I'm happy to practice more. But if you don't need help, we've got new work to get to. Remember, if we're adding, subtracting, we need common denominators. Questions? This is due by the end of the day today. Please get it in. You do not know what day we'll go to the homework contest, but you guys are competing for that prize. So please turn that in. If you were absent, I know you were absent. I've got it written down. You've got time to catch up. The other thing you need to turn in is the Chapter 4 Mastery Revisions. You guys should get quiet and whisper that. Sometimes people get more intense. They whisper. So guys, I will tell you, because I can look at my grade book and know real time right now. I can tell you how many of you owe me that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of, no, 10. 10 of you still owe me the Chapter 4 Mastery Revisions. I'm putting that in map tonight. So if you don't have it done, come talk to me. But also, if you don't have it done, I'll be here for math lunch at the very beginning. So go get your food, come down and work with me. John? What is this? What, 511? You already turned it in. I'm talking about the Chapter 4 Mastery Revisions. If you turned in 511 and you already got a check, you do not need to turn that in again. All right, let's do some percent work. So this is on your 511 paper. So I should have realized that if you kept it, that would have been better. But, you know, too many thoughts in my head. You don't need your paper to go over this. This was on the front of 511. But if you have your paper, you can go ahead and keep it out. We should do random cards. Because why would we not? So when we look at this picture, I don't know if I should shuffle. I don't know if I've made it through. I think I made it through most of these in the past couple of days. So, guys, when we start looking at math problems, some of what we do is just kind of observe and take in what's there. So as we get into the second half of the year, a lot of times when I'm doing cards, I'll probably say, tell me something that you see, right? Like not asking you a specific question. So, Kate's not here. Isabella, what do you see up here? Tell me something you notice. Sorry, I can't put it. It shows the split, or like the difference between the red and the blue. So we got 3 parts blue, and that stops right there. And then red's probably going to be a little intense, so I'm going to use pink. We've got 12 parts red. Okay, awesome, thank you. Farah, what do you notice? It goes from 0 to 100%. So I got into a thing in 3B yesterday about why is 100% 100%. Guys, what does percent mean? Per 100. So if we have 100 out of 100, we have all of it. Right? If you have 100 out of 100, you have all of what you want.
Excuse me, Phoenix. Stella Hickman, if you're in the building, please come to the nurse's office. Stella, please come to the nurse's office. Thank you.
Franco, what do you notice? Yeah, red and blue make purple. But, so, we had red, we had blue, we put them together. There's no going back. want to mix paint together, it's together. Layla, can you tell me how many total parts of paint we have here?
15.
See, they told us total, but they didn't tell us how many. So 15 total parts. Lucas, can you tell me how I could calculate what percent is blue?
First I turned, we know it's 15, and we know 3, so 3 out of 15. We know that much.
So hold on. Lucas is telling us exactly what to do. So on your graph paper, please, because a lot of today is just practicing percent problems.
What numbers?
Yeah, so this is still today's going to be a mix between lessons. So honestly, you could head your paper percent practice. It's 512, sort of, 513, but if you want to head your paper percent practice, did you not stick? We could call it percent practice. So we're going to practice some of the different percent formulas that we use. Now you're not going to work at all. There we go. To find a percent. So this is what we want to write down on our paper. Percent equals, it's right over here. When we want to find a percent, sorry my green marker is not that dark up here. Percent is part divided by whole. And then, and this is the thing people forget, and that's why sorry my sleeve keeps touching the screen. We have to do times 100. But if you get comfortable, you kind of like once you do the division in your calculator.
Teacher on here that can tell me if Stella Hickman is here today. She was not reported absent. Thank you.
The announcement came across the loudspeaker, so I can at least tell you that much.
She is not here. I can confirm she is not here. Okay, thank you.
So how many parts are blue? 3, right? 3 parts are blue. How many parts total? 15. So I'm going to erase where my sleeve is trying to write. What we're going to do is 3 divided by 15. And then we'll do times 100. But go ahead and do 3 divided by 15. This could also actually become a nicer fraction. Ooh, and that fraction can become a fraction with 100. Let me guess, 3 divided by 15 got you 0.2. Multiply that by 100, and you get the same thing I just got without a calculator. Some of our percent work is really nice. The numbers get along with each other. So put your pencil down for a second. Look up here. And guys, some of you, like, I can tell you're not writing down or you're not using your calculator. You're not doing what I ask. That's on you. You make that choice and then you don't know what you're doing. I mean, it's a bad choice, but that's how you learn, I guess. We did 3 parts blue out of 15 total. Percent out of 100. So if I can reduce my fraction, but then opposite of reduce, I don't really enlarge, increase, I don't know what to say, but then we get bigger. So here we did divide by 3. But then how do I turn 5 into 100? Times 20. So I did the same on top, and you get the same answer that you got in your calculator. Do you have to be able to do this? No. But when numbers are nice, you don't have to have a calculator. All right, so now this one's coming to you guys to try this because it's kind of potentially a head scratcher. You got to write down some information, probably work with each other. So if you're alone, you might want to hop like Jesus. You could hop over with Farah if you want. Turner Middle School has 110 boys. I would draw a squiggly line on your paper, by the way. We're doing a different problem. Turner Middle School has 110 boys. I would write down 110 boys. But 56% of the students are girls. How many total students go to this school? There are 110 boys. 56% is girls. And I'm sorry, this question just splits boys and girls. So if you're upset by that, like this is from a few years ago, back before we were really a bit more in tune with that stuff. So we're saying there's only boys and girls. Right? We're not going to have anybody in the middle on this problem. So label the percentage of girls, the percentage of boys, the number of boys, the number of girls. Pretty much label everything. So my advice, and what I'm asking you to do here really, is set up one of these models, the percent models, and break it up and label it in a way that helps you. Right, so I'm going to move this a little bit, and I'm going to give you a few minutes to work with each other. Get that out of the way. All right, 110 boys, 56% girls. How many total kids go to this school? Take a few minutes. I'm going to flip my timer to try to keep me honest. That's not the right way to flip it. What percent are we going to total up to? 100. Oh, yeah, because 100 is the total. What's that? Right, but that's not percent, that's people. You're right. So remember how on the bottom we normally write our percents? And on the top we normally write people? So Eve just kind of made the reminder to help us all out. This is going to be people, and the bottom is going to be percents. And then John and a few people told me when we total up our percents, we're going to end up at a total of 100%. 100% is our total. Any help or just thinking? Guys, I will tell you, I know this is a little hard to draw, but it's nicer for your brain if you draw like little brackets and put the numbers in the middle of the section. It's just kind of nicer for your brain. Yeah, be nice to your brain, Layla. If you do that, it's boys per percent. Or people per percent, if you want to say it that way. But like, so always think about your labels. If you do 110 divided by 44, that's people divided by percent. So you would be finding how many people is 1%. Okay? Vincent, can I pick on you when we come back together? on your own. All right, for the sake of helping some of you who are just kind of getting stuck, because we'll do another one of these. Antonella, can you tell me what percent would be boys? Yeah, because if we have 100% total, there's going to be 44% boys. Now, there are a lot of ways to solve this, but Vincent has a really interesting idea. Vincent? Wait, what? Say the labels.
If you divide 110 boys by 44%, you get 2.5 people per cent.
So guys, look. Drop your pencils for a second and look at what Vincent did. He said if I put 110 boys, or we could say people, since we're going to end up just talking about people, but people over percent, and he gets to 1% by dividing by 44, right? Proportion. How do I get here? I divide by 44. So Vincent said that came out to be 2.5. What this means is every 2.5 people, hopefully you're not the half person, every 2.5 people is 1%. So then, Vincent,
You multiply that by 100, and you get 250.
hey guys, are you listening or just talking to each other? Sorry, go ahead.
250 boys.
Ooh, not boys
No,
now.
people.
Now we have to switch it to just people because we're talking boys and girls.
For 100%, and then you can subtract the boys from the 250 people, and then that's how many girls you get. There's 140 girls.
So there must be 140 girls. Guys, I taught this in a bunch of different ways. I think the best way to make this make sense for our brain is using a proportion. Where I can put label to label, right? People to people, percent to percent. Now, there are other ways, and as we continue to do this, I'll probably teach you more ways. But what we've been doing this year is proportions. And then we do another proportion, and we're at our answer. We just have to do 2 proportions. And you're using calculators. So it's not like I'm asking you to do this in your head. See if this is the problem that I was wanting to. Yeah. This is a different situation, but similar. Is anyone still copying this? Maria is making paper flowers as decorations for the fall dance. Oh, I remember when we had dances. She has made 40 flowers so far. And that is 16% finished. She plans to get to 70% total tonight. How many more flowers does she need to make? So what you have is how many flowers is equal to 16%. Cough, cough, hint, hint. What Vincent did will work here. What you need is 70%. How many flowers? Chat with your team. Try to use Vincent's method. Ooh, we could call it the Meineke method. Such a good name. This is exactly kind of what I was talking to you about after class yesterday. Like, I didn't used to teach it like this. It just feels natural, right? Like what we've been doing is proportions. What percent are we trying to get to? 70.
So what is that telling us? Not percent. For every what? No. Because that, your 16% is telling us it's 40%.
We could jump right to 70. I hear some people chatting about in between, like a stop point.
Okay, so
We could jump right to 70.
1% is 0.5 flowers.
So one way that we would do this is draw an arrow, like we have done proportions before, and say, how do I get from 16 to 70? And we got to use multiplication. But if we don't know what to multiply by,
We're not dividing it.
division backwards. So draw that arrow and then use your calculator to figure out what is that multiplication going to be.
70%, right? So where would 70 go? Like on here. Draw yourself another. Okay, good. And then what goes up
Yeah.
there?
I don't know if I should use different colors.
2.5. 2.5 goes with the 1.
I don't know if that's any better.
So that right now we don't know what this is, right? Because we're looking for it. We're trying to find it. So how do we go from here to here? Is this 1 times 10 to the 7?
More imaginative base? What do you mean by that? The subtle way. Very what? I didn't tell you to go to 100%.
Well, we did.
There you go. So what is that?
All right, we'll have to test that because I don't know if I believe you, but you know that math people and math textbooks do that because they think it's funny. When you get the same answer, like the question I gave you on the chapter 4 test, where all the answers were the same. Vanessa, when you think about a proportion, are we adding or are we multiplying? Multiplying. And if we don't know what to multiply, Amanda, if you don't know how to multiply here, how can we figure it out? You can always pass, but I know you're catching up with stuff. Sorry, I couldn't hear what you said, but okay, totally fine. Marina, if we don't know how to multiply, what do? Divide backwards. Good with that, Amanda? If we don't know how to multiply, divide. So grab your calculator, do 70 divided by 16. And you may have already done that. What'd you get? 4.375. Kind of a weird number, but we can leave it in the calculator and just hit times 40. $175 flowers. Now, of course, I have a complaint from the crowd. Yeah, Vincent and John wanna complain to me. So, Vincent and John went ahead and said, what if we want to get to 100%? So they did the division to figure out how to get to 100%. 100 divided by 16, 6.25. They did that on the top, and what'd you guys get?
250.
They got the same answer that we just had. 250 people, 250 flowers. So actually, these two problems are kind of using the same problem. They're just giving you different pieces at the beginning. It's really kind of the same problem. Different numbers, totally different numbers, but it's kind of the same problem. Lucas,
Me entirely figured out a different way that worked through both of them.
did you break it down before you went up or what?
So 40, 16 can both be divided. They can both be divided by 4, which is the same thing that we did on the first problem. So we got 40 or 16 flowers, and then you would get 10 over 4, which is the same thing we got at the top, and then you can also break it down more, so it's 1 over 2.5.
Ooh, 2 point, how I have it written, 2.5 over 1.
Yeah.
And then to get to 70% or 100% or any percent. Guys, Lucas is showing us how to set up a proportion that can now get to any percent that you want. Whatever you want here, you just multiply that. That's really cool. Let's try another.
Isn't that what we did in the first problem?
Yep.
The Meineke method.
I mean, there are lots of ways to do these things. So the diagram is always a good way to think through stuff. And guys, this diagram is just a proportion. Look up here for a second. Number over percent. Number over percent. Number over percent. This is just a proportion. It just has a picture to go with it. And we all like pictures. I mean, come on. Anytime you got a chance to draw a picture, draw a picture. So, go ahead and draw one of these on your paper. And if you want to go ahead and put the splits, we got 60% and 40%. Marissa's getting a good deal. Gotta love a good deal. This rack of jeans is 40% off. Yeah, which means they upped the price so they can drop it. If the jeans normally cost $65, Eli, where would I put the what it normally costs on my model? Sorry, I can't hear you. Oh, at the end, so like with the 100%? So the normal price, what it regularly costs, that's 100%. So Eli said, put that $65 out here. I want you guys to calculate how much did she get off, but you're not allowed to use a calculator. You can use the Meineke method or the Sullivan solution or I'm trying to think up more, but now I'm on the spot. All right, we don't have enough time for me to think up more. Step 1, try to get this down to 10%. Step 2, take it from there. So if 65%, or if $65 is 100%. Guys, I promise you, you'll be shopping one day and you'll be like, oh, I just did what Mr. Hudson taught me. Cool. You might not say cool, but... Aiden, if I have 100% and I'm trying to get to 10%, what do I do? We divide by 10. Divide 10. Divide 10. What's 65 divided by 10? Move the decimal. Right? So this becomes 6.5 or $6.50. Guys, I don't want to use the E word, but make it less difficult. I don't have to jump right to 40%. Can I go to 20% from here? How would I get to 20%? Times 2. What's 650 times 2? $13. What's the discount that we're trying to actually find for her? 40%. How do I get from 20% to 40%? I need more colors. Again, we can multiply by 2. What's 13 times 2? 26 dollars. So we know the discount she got is $26 off of that original price. Eli? Oh, forgotten label. Now I will say, I will let you guys slide if you're missing labels in your work, as long as you have labels in your answers. Because I knew dollars was on top. But yeah, thank you, Eli. I appreciate the catch. We want to make sure that we remember what label goes on top and what label goes on bottom. They got to agree. So then, guys, we can subtract and find what she paid. Or we could have, from 20%, guys, can I turn 20% into 60%? How do I do that? Times 3. What's 13 times 3? 39. So I think she paid $39. What a deal. Some good jeans. A good price on jeans. All right, have a great day, guys. Hey, please don't lose. Oh, I didn't give this to you. Never mind. Because we didn't make it to that problem. So you have nothing to not lose. Here's a secret. I don't think it's very much of a secret. It's pretty obvious.
I think that's good.
So that's why I hadn't put the homeworks for Thursday and Friday up yet. Really, we'll be getting to 5-2-1 tomorrow. No, 5-1. I don't even know if we're going to make it out of 5-1-2 by tomorrow. I just want to take the time to really practice these problems. If you want to glance at this is kind of what we're doing tomorrow. So if you just want to have that ahead of time.
That's great.
What up? Meineke method.
Yeah.
You want to see me